Our home planet, Earth, may feel immense in our daily lives, but from a cosmic perspective, it is nothing more than a dust mote suspended in a sunbeam. When we look upward at the stars, we're not just looking at light, we're witnessing time itself. Photons traveling for millions or even billions of years before finally reaching our eyes. These stars serve as ancient messengers, silently reminding us of the staggering scale of the universe. It's natural to ask, where does it all end? Does the universe have an edge, or does it go on forever? The late Stephen Hawking, along with other brilliant physicists, spent their lives contemplating these questions. In 1917, Albert Einstein himself proposed the idea of an expanding universe, an idea he initially doubted until evidence from astronomers like Hubble proved it true. The theory of general relativity shows that space itself is not static. It stretches, causing galaxies to drift further and further apart. Today, we estimate the universe to be 13.8 billion years old. That would suggest a maximum distance of 13.8 billion light-years. But that's just the age of the light, not the size of the universe itself. Because the universe has been expanding all this time, the most distant galaxies we've observed are actually about 46.5 billion light-years away in every direction. That means the observable universe is a sphere with a diameter of 93 billion light-years. And yet, that is only what we can see. To understand the full scale of the universe, we must first ask a deeper question. What shape is it? Space isn't necessarily flat. According to Einstein's theories, the universe could be positively curved, like a sphere, negatively curved, like a saddle, or flat, like an infinite plane. Each shape implies a very different destiny for the cosmos. If the universe is positively curved, like a 3D sphere, it might eventually loop back on itself. If it's flat, it could go on forever. And if it's negatively curved, it could expand endlessly, but with increasingly strange effects on geometry and gravity. To test these ideas, scientists used satellites like the Planck Observatory to measure tiny temperature fluctuations in the cosmic microwave background, the ancient light left over from the Big Bang. These fluctuations revealed clues about the geometry of space itself. The verdict? Within a 0.4% margin of error, the universe appears to be flat. But here's the twist. Just because something appears flat doesn't mean it is. After all, the Earth looks flat to us on the ground. Only when viewed from space do we see its curvature. The same could be true for the universe. Astronomers ran calculations based on the largest curvature still allowed by the data, and discovered that the entire universe could be at least 250 times larger than the observable part. That means a potential span of over 23 trillion light-years. To measure the true size of the universe, we have to define what we mean by the universe in the first place. What we can observe from Earth is limited by the speed of light and the age of the cosmos. Because light takes time to travel, the farther away we look, the further back in time we see. This defines the boundary of the observable universe, a sphere about 93 billion light-years across, centered around us. But this isn't a physical edge. There's no wall, no cliff, no end. It's simply the limit of what light has had time to reach us since the beginning of time, since the Big Bang. Think of it like standing in the middle of a dark forest with a flashlight. You can only see as far as your light reaches, but the forest continues beyond your sight. Similarly, the universe may go on infinitely, or it may wrap around itself. We just don't know. At the farthest reaches of what we can observe lies the cosmic microwave background, CMB, a faint glow of residual radiation from just 380,000 years after the Big Bang. This is the earliest light we can detect, and it forms a kind of horizon beyond which the universe is opaque to us. Even more fascinating, this early light carries clues to the universe's birth, to its geometry expansion, and structure. And with powerful telescopes, we've captured snapshots of this ancient glow, effectively allowing us to look back in time nearly 14 billion years. But the question remains, what lies beyond the observable universe? There are a few possibilities. The universe is infinite. In this case, space goes on forever. Every direction we look would continue endlessly, with stars and galaxies beyond what we can see. The universe is finite but unbounded. Like the surface of a sphere, it loops back on itself. If you traveled far enough in one direction, you might eventually return to your starting point, though the scales involved are incomprehensibly large. There are multiple universes. Beyond our cosmic bubble could lie other universes entirely, with different laws of physics, what we call the multiverse. Each of these ideas challenges our understanding of existence, and yet all of them are consistent with current physics. One thing is certain, we will never be able to observe the entire universe, not even in theory. The fabric of space is expanding, and at such a rate that many galaxies are being pulled away from us faster than the speed of light, not because they're moving through space, but because space itself is stretching. That means there are parts of the universe we will never see. Not now, not ever, even if we had infinite time. But far from being depressing, this fact adds to the majesty and wonder of the cosmos. We are tiny participants in something so vast, so mysterious, that even our best efforts to measure it barely scratch the surface. Our story begins at home. Earth, a lush blue planet teeming with life, swirling clouds, deep oceans, and vast continents. It is the only known world where life exists, and the cradle of human civilization. From space, the signs of humanity are still visible. Cities glowing like circuits, fields of agriculture etched across the land. But as we rise higher, those details fade. Countries vanish, continents blur. Eventually, even Earth itself becomes just a sphere of blue and white, orbiting an ordinary yellow star. That star, of course, is our sun. It powers our world, drives our climate, and fuels life through photosynthesis. But it is just one among hundreds of billions in our galaxy. As we ascend farther, the other planets of our solar system come into view. Mars, Jupiter, Saturn, their moons and rings gliding silently through the dark. The vast architecture of our solar neighborhood spreads before us. Yet the sun, once all-important, now looks small. Just another light amid the blackness. Beyond the orbit of Neptune lies interstellar space. Here, the gravitational pull of the sun grows weak, and cosmic particles from the galaxy take over. At this point, we are leaving the realm of everything human beings have ever touched or visited. Now we see our solar system in its entirety, a tiny bubble in an ocean of stars. Zooming out further, we arrive at our galactic home, the Milky Way. It stretches over 100,000 light-years, a sprawling spiral of dust, gas, and hundreds of billions of stars. From this distance, even the sun disappears from sight. Our solar system is no longer a speck. It is lost in the blur. And the Milky Way? It too is just one galaxy among trillions. All around it are other galaxies, some larger, some smaller, forming webs and clusters, bound by gravity, dancing through space. They stretch into the cosmic web, a vast filamentary structure of matter, with great voids between the luminous strands. From here, we see the universe as a glowing network, billions of galaxies, each with billions of stars, each with its own possible planetary systems. And Earth? Earth is nowhere to be found. This is the true scale of the cosmos. It humbles us. It challenges us. It reminds us how fragile and brief our lives really are. And yet, it is in this vast emptiness that we exist. Every thought we've had, every moment of love, war, discovery, and creativity, All of it took place on a small rock orbiting a small star in a small corner of one galaxy.